To truly understand and implement this rolling wheel simulation for your projects, a solid grasp of mathematics and physics is absolutely essential. You'll need familiarity with trigonometry for slope, movement and gravity force calculations, vector math for collision responses, and Newtonian mechanics to model motion. The HTML provides a simple structure with just a header for controls and a canvas element for rendering. The CSS keeps everything clean and responsive, using viewport units to maintain full screen display and flexbox for proper element alignment. At the heart of this simulation lies an elliptical terrain generated mathematically, where we calculate heights using the equation of semi-ellipse. This curved landscape creates varying slopes that challenge our wheel's physics. The slope at any point is approximated by comparing nearby terrain heights. We take several adjacent points and compute the angle using math atan 2 for precision. Finding where the wheel touches the terrain is handled through method chaining. We filter terrain points near the wheel, map them to square distances, avoiding slow square root operations, then reduce to identify the closest contact point. This efficient approach minimizes calculations while maintaining accuracy. The physics engine shines in its velocity corrections during collisions. When the wheel penetrates the terrain, we calculate exactly how much to adjust both positions and velocity. The key is projecting the velocity vector onto the terrain normal and subtracting twice this component. This mirroring effect perfectly conserves energy during bounces. Angular velocity stays perfectly synchronized with linear movement through the simple relationship. Rolling resistance gently slows the wheel realistically, while gravity's acceleration down slopes follows trigonometric decomposition into parallel and perpendicular components. The entire simulation runs in a tight animation loop that recalculates positions, velocities, and rotations every frame, creating smooth motion that faithfully follows the laws of physics. This simulation is packed into one HTML file for simplicity. No extra files or setup needed. Just open it and it runs. The code is thoroughly commented, so you can explore how it works at your own pace without needed line-by-line explanations. At its core, it demonstrates key physics concepts: terrain generation, collision math, and energy-conserving velocity corrections. I did my best to keep the code concise and clean. If you spot any room for improvement, I'd welcome your insights. The link to the file location is in the description. I will scroll through the code now. That's all for now. Have a nice one.